Protandim NAD Synergizer. So obviously Protandim NAD Synergizer, it's one that's pretty close to my heart. It was the first product that I worked on after joining LifeVantage. And it's been fun to kind of see it come to fruition. And, you know, I think last year between all of our international markets, we launched over 17 products, if memory serves. And I tell you, it never gets old to see a product launch, like when you actually hold the new product in your hand. So being that Protandim NAD Synergizer was the first product I worked on, it's pretty close to my heart. And the story is continuing to develop. I'll kind of maybe end with the punchline. But we recently just finished up with our strategic partners out at Auburn University and then a private research center out of New York, New Jersey, finished up a human clinical study. The results, I can't say too much about it, but it's going to be broken out into at least 3, if not 4 different publications. And the results are pretty darn phenomenal. So stay tuned. You'll be hearing more from us as those publications start to come out, and we'll have a lot more to talk about around Protandim NAD Synergizer. But as the name would suggest, Protandim NAD Synergizer, its whole aim is to be able to increase this molecule inside of our bodies that's called NAD. And if you were on last week, we talked a lot about the mitochondria. I showed this really complicated schematic about just how elegantly the mitochondria picks electrons out of the food that we eat and runs them through this machinery that ultimately generates energy in the form of ATP for the cell. So just to orientate everybody back to why NAD is so important. And I should say too, I know Greg and Rye, they put these weekly presentations up online. So if you did miss last week's, I encourage you to go back and have a watch, and we can talk about mitochondria. But again, to orientate us all to where we're at with NAD, the majority of NAD in our body is found inside of the mitochondria, but it is found everywhere inside of the cell. And if you can see my cursor, here we'll have NAD. And if you look closely at it, it's the technical scientific name is NAD plus. So what NAD plus means is that it's still able to accept an electron. And so it's getting those electrons again from the food that we eat through this citric acid cycle. So once NAD plus receives that electron, it then becomes NADH. So that just basically means it has that electron on it, and it donates it up to this energy producing machinery in the mitochondria. So this is so interesting because, gosh, I believe it started in either the late 80s or early 90s. There were a set of studies that were done in yeast where if they put somewhere between 40 to 60% fewer calories as these yeast were growing, they found that these yeast could actually live about that same 40 to 60% longer. So that's weird, right? Restricting calories actually increased lifespan. And they've gone on to repeat this in worms, fruit flies, mice, rats. They've started studies as well in monkeys. But how applicable this extreme caloric restriction is in humans, it's probably not very attainable for most. And quite frankly, it's going to be a miserable existence. To put that 40 to 60% reduction in calories into some perspective, that would mean someone my size and my caloric intake would only be able to eat about 700 to 800 calories per day, right? It's absolutely miserable. So anyway, how attainable is that for humans? Probably not that attainable. I tell you this story because as these studies went on and the molecular biologists got hold of this notion that reducing calorie intake can increase lifespan, they wanted to figure out exactly how all of that was working. And a really long scientific story short, what they found is that when you were reducing caloric intake, you were actually increasing the concentrations of this molecule NAD plus inside of the mitochondria and the cell. And it actually went on to be a signaling molecule. So as these molecular biologists and geneticists started to go in and tease the model apart, what they found is that if they deleted or inhibited this class of proteins called sirtuins, you lost that increase in lifespan. So you still reduced the calories and you no longer had the life extension. So the conclusion is that these sirtuins are absolutely essential for this notion of caloric restriction. So how is that interesting, and how does that tie back to the mitochondria? Well, it turns out that these proteins, the sirtuins, use NAD as a co-substrate in that enzymatic biochemical reaction where sirtuins are going on and doing their jobs inside of the cell, meaning that NAD is actually chewed up and consumed as part of the process. Okay, why is that ultimately interesting? So now you have caloric restriction increases NAD. NAD is required for these sirtuin proteins. Why is that so significant? It's so significant because now you have a direct tie between being able to measure what's going on metabolically inside of the cell, and then the cell ultimately reacting and responding to that situation. So, being that only eating around 700 calories wouldn't be an amazing lifestyle for most of us, scientists turn their attention to ways that you could actually increase your NAD levels without having to do all that caloric restriction. So here, forgive me, this is a little bit scientific, but this is the NAD biosynthetic pathway. So if I highlight here, you can see NAD. NAD is made in two different ways. It's basically made from scratch inside of the cell, mostly inside of the liver, but then it also can come from recycling that NAD that's been partially chewed up as part of these chemical reactions. And this is called the salvage pathway. And this is the most important part of being able to make NAD. And again, if you remember us talking last week, that flux of energy that's going through the mitochondria is just absolutely massive. And if you shut down NAD biosynthesis for even just a very short period of time, it's going to compromise our health, and we very quickly die as a result, right? And again, that's just because of that energy flux that's going through that mitochondria. So we constantly have to have new NAD being made so that it can keep that energy production going, okay? So as we look at what are some of these precursors to make NAD, we have a couple of amino acids here, as well as a form of niacin. When we look over here, there is a different set of precursors that we can use, another form of niacin, as well as some other precursors that I think some of you may have heard of in the scientific literature and from some of our competitors, quite frankly, and that mostly being nicotinamide riboside. Maybe you've heard of Professor Sinclair as well. He's a big advocate on this compound called NMN. So it's a way to get around one of these regulatory steps in the synthetic pathway, and is also serving as a precursor to get to NAD. So why is that so important? Because if we start with these most basic of precursors, it's going to ultimately take two enzymes, an enzyme called NAMPT to first make this compound NMN, and a second enzyme called NMNAT to ultimately make NAD. So if we call those two out, it turns out that these enzymes are absolutely critical to regulate the production of NAD.
So while you're pulling that up, Brian, I think that was one of the questions from the field that were submitted was a lot of that, I guess Dr. Sinclair's or David Sinclair's NMN product. And he kind of mentioned, I don't know what products there compared NAD to those first product slides, but that just kind of the comparison of the Sinclair NMN as opposed to ours and what's leading up to that.
Yeah. Yeah, that's a great question. And that was
Exciting news, right? I mean, a lot of the field is really kind of dissecting this, and as far as Nerf one, we don't really have any competition in the space with regards to Nerf one. When it comes to NAD, we do have a few, in the space that are on to this specific product, which the way I look at it is we're still the leading foremost expert and running, out in front. But it also excites me knowing that there's other people that are attracted to the same thing that we're excited about.
Yeah, that's exactly right. And I think by the time I kind of run through some of these cartoons, I think you will see why our approach is far superior than this nicotinamide riboside or NR or the NMN approach as well. All right, so if I come back to this kind of biochemical pathway schematic I was showing you, right? We have those two enzymes. So why do these two enzymes become very important when we're trying to increase the concentrations of NAD? And so some simple cartoons that I threw together here is this kind of analogy of a factory. So if we kind of look at this top line, or I should say this bottom line, and we're using a factory as an analogy, right? Kind of at the back doors of the factories, we pile up all of this raw materials, whatever it might be, to make our widget. So let's say maybe our widget is a car. So maybe we're piling a whole bunch of steel at the back door, and we need to run that steel through the factory assembly line to ultimately get our widgets or our cars out. And this is, in my mind, a good analogy for what the cell is doing as a whole. The cell, if we look at it, is really just a factory. It's taking all of the raw materials that we're putting in our body, right? These nutrients that it's using as raw materials or molecular building blocks to ultimately get into the cell, so the cell can make whatever it needs to be able to conduct its function, or these active molecules that are out. But if we kind of drill down into this factory analogy, so let's say there's a bunch of workers that are lined up having to put these widgets together. So worker number one is going to be putting the first thing on to our raw materials to start to make our widget, then worker two, then worker three, on down the line until we get our completed widget. But what would happen in this assembly line if somewhere right there in the middle there was a worker that was slow, that wasn't able to keep up with the pace of everybody else? What's going to happen to those widgets that are being made? Ultimately, what's going to happen, because the slow worker is here, these widgets are going to start to back up at this worker, leaving these two workers as well not to work as quickly as they could, because there's effectively a choke point in the process. And so enzymes in a biochemical pathway are working just like these workers are, okay? So any biochemical pathway can only work as fast as the slowest enzyme. Okay, so here we just have a generic biochemical pathway. So here we have kind of our raw materials or building blocks coming in. Enzyme one has to put everything together, and then you make this first intermediate or first step in that factory process. Then enzyme two is going to come on and put whatever it needs to add to that widget. And then enzyme three is going to do the same thing. And eventually we end up with our end product, or that active molecule inside of the cell. But if this enzyme is our slowest enzyme, I should say enzyme 2 is our slowest enzyme, the same thing's going to happen where this first intermediate is going to build up. And so enzyme 3, no matter how quickly it's working, will be able to work as quickly as it can because it's limited by what it's receiving from enzyme 2. Is this hitting with everyone? Ryan, are you guys all with me still? I know it's a little bit
Absolutely.
complicated.
No, it's not. I mean, just to be able to see the visual with comparisons to a factory, I mean, it's no different than an assembly line on whether we're making cars. There's bottlenecks and everything. And really, you truly become the bottleneck or as good as your bottleneck is. What the beautiful thing is when you start to streamline those bottlenecks, it always causes another bottleneck. And that would be the question that I would ask is, as we get really efficient with that particular enzyme to where it's producing, can it produce faster to where it creates another? Hey guys, can you zoom? Greg, can you mute everyone out, please?
Heard a lot on it. Be very good for
or make me co-host and I can monitor that, please.
She's gonna start.
All right. So Brian, go ahead with that. So this makes perfect sense. And if I'm getting it, I promise you every single person on here is getting it.
Right on. Cool. All right. So scientifically, if this is kind of this choke point, because it's the slowest enzyme in science, it's called the rate limiting enzyme. It's this enzyme that's limiting the rate of how quickly this assembly line inside of the cell can put things together. So maybe a different way to look at this would be like a funnel. So you can put a lot of material into the top of a funnel, but if we're putting water into the top, water's only going to be able to move as quickly through that funnel as the narrowest point in that funnel, where that effectively choke point is going to be. So this is pretty analogous to the factories or using these precursors to try to increase NAD levels, because you can put all the raw materials into this assembly line that you want, but it's only going to move through the system as quickly as whatever choke point will allow it to occur. So effectively, what we're trying to do using our nutrigenomic approach isn't to just stack up a whole bunch of these molecular building blocks or raw materials at the beginning of this assembly line. What we're effectively trying to do is actually make more assembly lines inside of the factory. So by using our nutrigenomic approaches to upregulate the enzymes that are involved in NAD synthesis, we can effectively double, triple, quadruple how quickly NAD is being made inside of the cell. So if I come back to...
Is it fair to say we streamline the bottleneck, but we also create more factories in the bottle by consuming NAD?
Yeah, we've alleviated the bottleneck because we've put more factories in, more assembly lines inside of the cell. So think if you had a factory and you wanted to increase productivity, right? Your assembly line is going to be limited by your slowest worker or your slowest piece of machinery. And the only way to overcome that is to make another assembly line so that you can effectively double output once you've reached that maximum capacity.
Love it.
And so if we're looking at this kind of this linear approach, it wouldn't matter how much of these raw materials or steel I put out back of the building. The assembly line is only going to work as fast as those enzymes can work. And we can pile up these raw materials all day long, but they're never going to move through the system. So with our nutrigenomic approach, what we're trying to do is make more enzymes so that we're effectively building more assembly lines for NAD inside of the cell. And so this is that same biochemical pathway that I was showing you earlier, just kind of cut it down a little bit to just look at this de novo synthesis. So if we looked at, in this case, one of the precursors, nicotinamide riboside, from what a couple of our competitors, they're using that substrate or raw material approach to be able to drive that reaction. But it turns out that it's this first enzyme that is the choke point, or that rate limiting enzyme in the production of NAD. So it doesn't matter how much nicotinamide riboside or other forms of niacin we pile up out back of that factory, it's only going to make it as fast as that enzyme NAMPT will allow. Okay. So this is effectively what the competition is doing. They're just piling up these raw materials, when our approach is to try to make more of the enzymes responsible for making NAD. And so what's really powerful with our approach is we know scientifically, both from studies we've done internally, as well as studies done by our strategic partners, done completely independently, but have confirmed each other's results, that we can indeed increase the activity of these genes, effectively making more of the enzymes to make more NAD. And on top of that, we do also add a little bit of niacin in Protandim NAD Synergizer to also act as some of that initial substrate. So you make sure you have enough substrate, even when you're increasing the number of enzymes involved in the production of NAD. And so, like I said, we've got these two cell culture studies that have been done that verify this. And now we have this human study that should be coming out and published later this month. So really strong scientific evidence that we are indeed able to increase NAD plus levels in humans. And we are the first company that is able to say that.
Woo, that's incredible. Like, I am jacked up right now, man. Like, understanding this in a layman's term with regards to how this fits into our product line, how it fits into our message, how it fits into anything and everything that we're doing. And mainly the reason for this call, Brian, is we want to raise the belief, right? Raise the belief that we can really go out and talk, apples to apples with people. And I think it's really simple. We're streamlining the production assembly line, but then we're also adding more assembly lines within the cell so that we can shove more raw material through and perform at our highest levels, whether that's mood, whether it's cardiovascular, whether that's joint, whether it's sleeping patterns, digestion. It's all encompassing, right?
Absolutely. Absolutely.
So let me ask you, there's an interesting thing that we all know, that sirtuins actually decrease as we get older. We know that. Does it run along the same parallel as our body's ability to increase antioxidants, or that antioxidant level starts to decrease as we get older? Is that in parallel with all of this stuff? Is it all in conjunction?
Yeah, absolutely. So NAD levels decline with age. Sirtuin activity declines with age. And also really interesting, these two enzymes, and especially NAMPT, also declines with age. So now we have this kind of triple deck that's stacked against us when it comes to NAD production inside of our bodies. Mm-hmm. So we're not making as much. The enzymes working slower, probably a major reason why we're not making as much. And then there's also fewer sirtuins around as well. So we want to make sure we're able to nutrigenomically activate all of those things. And we've also been able to show, and something we haven't really shared, but we've also been able to show that we can increase the gene expression of these sirtuin proteins as well. So we're really coming at it from all the different angles that have been shown to be deficient, especially as we start to age.
Man, I would have to say, and it's not just because of this call, but I would have to say the last 3 weeks, I have a better understanding of this Tri-Synergizer than I ever have in my 4 years. And so thank you. It's been a tremendous insight. And we've got some great questions in the chat. There's one by Jude that says, is it also about delivery? And what he means by that is there's injection versus consumption. Is there any insight on that?
Yeah, for sure. The whole rationale for injections is interesting because NAD it's a relatively big molecule. And so you're not able to supplement with actual NAD to increase your NAD levels. Our digestive system just basically breaks it down back into its parts. So it'd be a lot like taking glutathione. You get very little benefit from actually taking supplemental glutathione because very similar to NAD, our bodies have to make it. So you can't take an NAD supplement and expect your NAD levels to increase just because our bodies break it down when it's being absorbed. And what was the second part of that question, right?
That was it. I mean, so let me ask you this. So clearly NAD is an activator, a lot like the NRF1 and just like NRF2, correct?
Yeah, absolutely. That's exactly how it was developed.
That's beautiful. One of the questions that came up too, Brian, is, and this is pretty interesting. I think we had this question come up in our NRF2 video, where why do some people instantly feel, this, oh my goodness, I got energy and my sleeping patterns changed, my digestion changed instantly, and others don't feel a thing. And the question is why do some people feel lethargic when taking NAD as opposed to others actually seeing or feeling an increase of energy?
Yeah, it's a great question. And at the end of the day, I mean, we are all different. It's crazy as a molecular biologist and somewhat of an amateur geneticist, when you're honing in on that level of minutia, everything is the same, and we're almost all the same no matter what organism we're talking about. So on that molecular level, we're very similar. On the genetic level, we're very similar. But there are very clearly just differences in us being human beings. So the small percent differences that we do see in DNA and some of this molecular biology does account for some individuality in people. And maybe the best analogy I can give you is a coffee drinker. I love to have one cup of coffee, first thing in the morning. It's what gets me out of bed, and then I'm done. And I have a really hard, strict rule that I don't have caffeine after 2 or 3 in the afternoon. It affects my sleeping patterns. Whereas I think we all know that individual that can have a double espresso and go straight to bed, right? Like my wife, for example. So we do respond differently to different compounds. And when we start talking about compounds like caffeine, they very clearly affect people differently. Some people get tired after drinking caffeine. But the simple solution I can give to that is we still know we're going to be delivering the health benefits. And then if you are somebody who takes the product, does feel a little bit lethargic. In fact, my wife is one of them. Just switch it up from taking it in the morning to taking it at night. Just a very simple solution. And, we hear similar things with Protandim NRF1 Synergizer, Protandim NRF2 Synergizer as well. So kind of self-experiment a little bit on yourself and figure out when is that best time of day to take the products.
Yeah, I appreciate that insight. And I'm one of those drinkers that I can have, coffee, I can have a Coca-Cola and go right to bed, which is a gift. And I appreciate that gift that I've been given. But one of the questions that I think would be relevant to today's topic, because we do see there's so many people that we subscribe, new subscribers to LifeVantage. Obviously, to me, a new subscriber is obviously a new customer. And anytime I hear new customer, there's this knowledge or this mountain of information that we try to, obviously give them the best of our knowledge, but we don't want to scare them away as well. And so what I've seen a lot of the distributors do, and I don't know what's the right or wrong answer, to me, it's to start out immediately with the Synergizer with all 3. Is that something that we should be doing to the newbies that are starting out with regards to where they are health-wise, or maybe they are a little bit overweight? Are they going to feel too much to where they get sick? How should we go about it? All at once and start from the word go, or phase in NRF 2, NRF 1, and NRF 3 or NAD to the point where they can work up to that? And that's just a question from the field.
Yeah, it's a great question, and I think there's a maybe an underlying question here, and that this is some whispers that I've heard that, quote unquote, a lot of people don't feel well when they're taking Protandim NAD Synergizer. So I'll come back to that point in just a second. But to go to your question, I would just go straight to the Tri-Synergizer, and just I can tell you from the data, the majority of individuals are going to experience positive results. Okay. So I would start there. And then if issues come up, then I think we can troubleshoot. We can back off dosages a little bit if we need, and then maybe ramp them back up. But, I've, like I mentioned early on, Protandim NAD Synergizer is pretty close to my heart. It's a product that unbelievably excited about. I do admit that when we rolled it out, because we were an early adopter to this technology, we didn't have in place a lot of that direct cause and effect research where we can say Protandim NAD Synergizer is going to help with your cardiovascular health. It's going to help with your lipid profiles. It's going to increase your NAD levels. So we had to tell this kind of complicated, circuitous message around the science and sirtuins and all of this. It was complicated, but you're going to start to see those messages really quickly become pretty streamlined and getting right to the health benefits of taking the product. But back to this underlying tone that a lot of people can't take Protandim NAD Synergizer. When Protandim NAD Synergizer was launched in October of 19, because there was a compound in there that's similar to caffeine, I wanted to make sure that there were no adverse events coming through. The one population that shouldn't be taking caffeine is somebody who has, let's say, high blood pressure. And we're talking pretty high blood pressure. So I just wanted to make sure that, of course, we were doing no harm and having health benefits, and something that we track, on a daily basis, but we get together as a group of teams once a quarter, is we go through all of the adverse events. We call them adverse events, and it can be anything from a broken tablet to a broken seal on a bottle to maybe a serious condition that puts somebody in the hospital. So we call them adverse events, but they can really span the spectrum. So I've been tracking those adverse events since literally the day it was launched, and we just had our quarterly meeting for adverse events. And I think a lot of people on this call will be shocked to hear that Protandim NAD Synergizer has the lowest adverse event rate of any product in our product portfolio.
Wow.
I think that's pretty shocking. And just for fun, I mean, what product would you guess has the highest number of complaints?
I would say Nerf 2 because it's been around the longest and it's our biggest product and we've sold billions, but
it is. So by number, and you're exactly right, because it is our top selling product. It is Protandim NRF2 Synergizer. But when you correct for the units sold, still Protandim NAD Synergizer has the lowest adverse event rate of any product in our portfolio. On top of that, this human study that was conducted, part of the study also had to look for adverse events, and they reported absolutely zero adverse events in this human clinical that just came out. And that's not to dismiss any one individual's experience with the product, but when we look at populations as a whole, we can glean a lot of data. And since the launch, all data has indicated that this is an incredibly safe and effective product that's well tolerated.